Okay, hello everyone, wherever you're watching from. Good morning, good evening, good afternoon. I think you just caught me getting a quick drink here, so apologies there. But welcome to another episode of Howdy Partner today. My name is Jeong. I'm a partner SA here at AWS and one of the hosts of the show, and we'll talk about what the show is in a little bit. But with me over here, this way, is my co-host, and for the first time hosting James Spencer. James, you want to go ahead and introduce yourself?
Yeah, thanks, Young. Hey, everybody. Howdy. I am James Spencer. I am also a partner solutions architect here at AWS. We're going to be talking to Wayne Brown from AppDynamics, and we're going to be talking about Lambda services, specifically Lambda extensions and function URLs. For most of you who are familiar, Lambda is a serverless service that we have here at AWS. It runs your code. You don't have to worry about any of the underlying infrastructure you have to do. It's typically triggered by an event. Anything that happens, you could utilize Event Bridge, API Gateway, something like that. That's most typical ways. They've also were a launch partner for the Lambda extension API. Lambda extensions are typically the best way to kind of customize your different Lambda functions before, during, and after their invocation. During those, when those events get called, you can instrument your code without changing it, fetch configuration settings, send telemetry, all those kind of things. And finally, one of our brand new services, it's really cool. It's called a function URL. It actually eliminates the need for an API gateway if you need to, and can just be able to trigger those Lambda functions using HTTP requests. And that can help cut down on your costs and kind of simplify your architecture a little bit. They were able to incorporate all these and ingest metrics and logs and actually give you a good visualization of all the different Lambda services you can utilize. And I'm going to go ahead and throw it over to them for a little bit. Hopefully I didn't miss anything. But
Just before we jump there,
yeah, no
I know you
problem.
cover a lot of stuff. Um, for those of you who have watched us before, I appreciate you coming back on. Those of you, if this is your first time watching us, Howdy Partner is a show on Twitch, as you can see. It's a live show where we bring our guests, our partners. So we have partners within our AWS Partner Network that builds with us on, integrate with us, builds on AWS, and really what they do is on top of what we already offer, and I think James covered it pretty well uh, in terms of AWS services or the features that come out. We have partners that build it on top of us to kind of enhance your cloud experience. And today we're going to be talking about obviously a serverless. Um, and now will be a good time to turn on the ticker to kind of explain what I just said. Today we're going to be talking to Wayne from AppDynamics, and to kind of help with us, kind of get deeper into what AppDynamics does. We also have Todd, a PSA from AWS, working with AppDynamics. So over to you guys.
All right, great. So thanks so much for joining us today. We're super excited that you're attending our live stream in terms of the serverless instrumentation aspects of what AppDynamics can bring to the table, and how they've been integrated with a lot of the serverless technologies from AWS. The reason why we're so excited is because of the established place in terms of observability that AppDynamics, the presence that they have in the industry today. And then having worked with them very, very closely for the past few years, they've been a part of a lot of our launches. We already mentioned a couple of the bigger one, the AWS Lambda extensions. So we'll talk about that in a little bit more detail. And then we'll talk about some of the work that we've done with AWS function URLs. We have a cool demo to show all of you today. So we're super excited to run through that demo, answer any questions that we have here on stream. So with that, I'll go ahead and I will pass it over to Wayne. So Wayne, maybe we can do a quick introduction on some of the work that we've done and then introduce the AppDynamics platform.
Yeah, absolutely. Thanks, Todd. Hello, everybody out there. My name is Wayne Brown. I am a cloud channel solution engineer with AppDynamics. My primary responsibility is helping our customers who are focused around AWS deployments and helping them get observability into their workloads and applications that are running on AWS, and helping not only observe and monitor those applications, but also tie it back to the business. So that's a quick intro for myself. Go ahead and swap over to my. I don't know if we could see the screen that I'm sharing, so I can talk a little bit about what we're doing. There we go. That looks better. So for those who may not be familiar with AppDynamics, the way we like to, say what we do is we monitor the things that matter for your business, because we know that applications are what drive the business nowadays. From whether it's, something that's powering the e-commerce platform to, running financial services, trading platforms, the infrastructure, is backing it. We have network connectivity that helps us, keep our services connected to one another. But ultimately, it's that application and those services within the application that bring revenue in for our business. And so it's really important for us to understand that, being able to make that correlation between how is my application and how are my services within my application performing, and then be able to tie that back to how is my business doing, because those are the things that really matter when it comes to, come to organizations and their viability. So what we're looking at here right now is, a home screen for an application and various services that I'm monitoring within AppDynamics. On this screen here, we can see, different nodes and different circles on this graph. And these represent the services and the service instances that are running within our application. Not only do we see, what services are there, we also see what languages those services are built in. In this case, we have a mix of Java and Node.js. We also see how data flows are going between each of those services. We see latencies between, calls that are being made. We also see performance of the individual services. And we also see, details about things that we are reaching out to that we may not necessarily be monitoring at this time. Spoiler alert: we're going to be putting monitoring on some of those so that you can see those. Whether it is to third-party HTTP services, or we're connecting into various databases such as MySQL or MongoDB, or if we're going through some kind of messaging queue, we're able to surface up all of that and show you how data is flowing between the different parts of your application. But where we start to differentiate ourselves a little bit is we then take it a step further and we put it into context. And so we call this business transactions. And business transactions are nothing more than how your users and how your customers are interacting with your application. For the example here, we've actually done a modification to the AppDynamics AWS Lambda workshop, which is available at d-serverless.awsworkshop.io. And so we're going to be following along pretty closely with that, but we have made a few modifications to this, and I'll show you, the ways that we have modified this. Todd, hopefully I covered it. Was there anything that I can answer from you?
You did. I was thinking maybe we can just bring up that URL of the workshop, Wayne, real quick, as everyone gets the link on their end. Maybe we can kind of jump into the extensions API portion of it where we show that diagram. But yes, you summarized it very well, right? So while you do that, the overall, what Wayne's really double clicking on, the value add, is just the overall topological representation of all your application components within that dashboard that he was showing. So in one quick glance, if you will, you're able to visualize how your application is performing, right? And in addition to that, the system itself, every system that you have, they're interacting with each other in real time. So you're able to measure, score that. If there's any issues, you can find root cause analysis, and there's much more functionality. But from a serverless perspective, what we wanted to do is just bring up this workshop here. This has been pre-written out for everyone. It's public. You guys on your own time can spin up your own AppDynamics environment, your own AppDynamics controller, and create the level of serverless instrumentation that we're going to get into. But I think if we go back to what James had introduced, I'd like to add a little bit on top of that, because it'll really set the context and groundwork, right, Wayne, as you go through this demo and show the AppD specifics. So if you guys think about AWS Lambda in itself, it's really it provides this sandbox environment. And the reason why it's real important and with the visualization that you see today is because it's underlying managed compute service where your function code is actually running, right? And that environment itself, it isolates all of your function from the other AWS Lambda functions that are out there today. And in doing so, it provides a lot of the resources as well, the resource level visibility. Think about memory, right? And that's specified within the function's configuration as you go through it. So when the Lambda service, and this is kind of a chronological of events I'll take you through to kind of set up the demo here. When it initializes this environment, this sandbox environment, it happens through the first invocation, right? And in advance, it'll turn it on, or if you want to have it invoked and initialized beforehand, you can use what we refer to as the provision concurrency, of course. And that's what keeps the functions initialized and ready to run at really double-digit millisecond latency, right? So for that use case of latency-sensitive use cases. But when you invoke the Lambda function, the service actually routes the request to the environment that we had talked about, that sandbox environment, where your code processes the request. Now, interestingly enough, there's the API that's referred to as the runtime API, and that's what invokes the function handler, which is what we code along with the business logic that the function will be running, right? So that's what we talk about. Don't worry about the compute, run the business logic and just code whatever the business really needs. And after that function code is done, it returns the response back to that runtime API. And it asks for the invocation event, the next one that's happening. That's really the life cycle of events that happens, because if there aren't any more invocations that are coming in, then the Lambda service itself will freeze the environment. So how do we have visibility into that environment? And that's where Lambda extensions, AWS Lambda extensions really comes into place, because it's a way and a mechanism for tools, whether they're open source tools, or in this case, the partner tools like AppDynamics and what Wayne's created on his end, to integrate very deeply into the Lambda execution environment, that sandbox that we had talked about. And it's doing so it can control and participate in Lambda's lifecycle, right? From initialization, invocation, when it freezes, when it is torn down, etc. So the reason why that's important is because the extension API will help register all the lifecycle events that are happening. It'll process them. It'll talk to the Lambda service, and when it's finished, it'll provide all of those metrics, logs, and feedback directly back to the AppDynamics platform. So that's really the interesting part of it. And the way I think about it is that it's really a companion process, right? You are running this companion process in parallel to the runtime, or you can actually do it outside of the runtime as well, meaning that the process can run before the initialization happens or when the execution is complete. It does use some of the resources, but having that level of instrumentation outside of the AWS console is key. And that's what Wayne's going to step into here today and talk about it in terms of how AppD has deployed it within their controller and their platform.
Perfect. Yeah, so to continue on the path that you're going down, Todd, I'll set up a little bit of context around our sandboxed application here. So this is an application that is part of a fictitious organization called AD Financial. And contrary to the way things are going nowadays, they're experiencing a rapid amount of growth. And so they have their online, HR job application portal. So what we've been tasked with, and we go a little bit into the story around this, is we've been tasked with kind of doing the migration from more legacy services into that more serverless, flexible model, to just allow for that, bursting of traffic and allow for that flexibility and that consumption-based model. For the lab here, the application is deployed as a Docker Compose application. I will show exactly how that is set up. So it's just a pretty standard Docker Compose application. Everything is containerized. And when we go into our application within AppDynamics, we have attached agents to the different services that are not Lambda based right now. And so those are being represented up into our flow map here. So what we're planning to accomplish today during this session is we're going to add in instrumentation to our Lambda functions that are powering our sandbox and lab environment. In this lab environment, we have Lambda functions that are written in Java, Node.js, and Python. For this, we're going to do 2 out of the 3. We're going to do Node.js Lambda functions, and we're going to do Python-based Lambda functions. Hopefully that sounds good for everyone. If you're interested in taking a look at how Java functions are instrumented, that is part of the lab guide. So please feel free to, pursue it in your own time and open up the, open up the lab environment and, dive in and take a look and walk through the steps. So, and here's a diagram of how our Lambda functions are set up. We have Lambda functions that are talking to, we have Lambda functions that are communicating to another downstream Lambda function, and those will then be pushing data into an S3 bucket as well as DynamoDB. Then as we're getting our tracing in and we're starting to send our traces over, those will be sent over to AppDynamics. And all of that trace data for this application is going to be collated together, and it's going to be serviced up in the controller screen that we were just looking at. Todd, if that sounds good with you, we'll go ahead and get started.
Yep, that sounds great. I mean, we had a comment that came in around how does the monitoring integrate into the AWS account itself. So I think that's actually very interesting, right? And Wayne, you'll touch on that. We're going to show some of the metrics and logs that we can field on behalf of this integration.
Yep. So there are going to be 2 pieces that we show here. The first piece is going to be surfacing up the traces within our dashboard. The second piece is going to be showing how we actually ingest some of the CloudWatch metrics that are generated from, invocations of these Lambda functions. So we're going to tackle it from those 2 perspectives. I hope that answered the question. If not, please, chime back in and I'll answer it as best as possible. If not, we'll go ahead and get started with this.
Yeah, and Wayne, just to add, this is all in addition to what's already been a very tight integration with Amazon CloudWatch to power the AppDynamics platform. You can think about leveraging, for example, the Amazon CloudWatch Get Metrics Data API, where literally in one call you can have hundreds to thousands of different metrics that are being sent back over to the platform and then visualized within dashboards. And by that, I mean EC2, CPU utilization, the RDS database read-write, if you will, or understanding load balancers and how many healthy instances that there are within the target group. So there's already a very tight integration with Amazon CloudWatch. This is bringing over the serverless components as well in terms of both the extensions, the invocations, initializations, the latency, everything that you want to know about AWS Lambda. We're enriching that with the AppDynamics platform.
Yep, exactly. And so as you may be, making a bit of a journey as you're starting to move workloads from more legacy deployments and start taking advantage of more cloud native constructs, using a tool like AppDynamics will really help you bridge that gap and will help you get that, visibility into not just the cloud native pieces, but also kind of the overall enterprise and how things are talking to one another. So we're going to go ahead and get started. I'm going to briefly talk about, how we set up our environment. So for this, we did pre-configure our environment and did do the, install and set up ahead of time, because that would take about 10 to 15 minutes, and nobody wants to watch text scrolling in dead silence for 15 minutes. So as part of the lab, the first step we did was we installed some of the necessary tooling that was needed to accomplish this lab. To be able to manage our AWS resources, we're using the serverless framework, which piggybacks on top of AWS CloudFormation to be able to build out and to manage the resources within AWS. We also installed different things such as Node.js. We installed NPM. We installed Java, because as part of this Java, we do, part of the Java portion of the lab, we do compile everything, and we do compile the Lambda functions before we package them up and send them over into AWS. And we also install some, helper libraries and some other utilities to, help with the scripting, such as we install JQ to, do some of the dynamic, extrapolating of data from, from some of the output. We also install Docker Compose to actually run our lab application. And the setup for this takes a little bit less than 5 minutes to install all of this. Then once we have installed our tooling, we then go and actually set up our application and do an initial deployment of all of our Lambda functions. So for each language that we have as part of the lab, we're doing 2 different Lambda functions, and the second Lambda function, and I believe the first Lambda function, will eventually also make a call into another AWS resource, whether that is DynamoDB or if it's S3. Those are the 2 examples that we have here in this lab. So the first part of this, we give you access to an AppDynamics controller. Once we have that access provisioned, we then start deploying our different Lambda functions. If you're interested in the dirty details, the script is in setup.sh. We can go in and take a look at those. You can see how those are being deployed, and then we're pulling all of the appropriate data out of those. And then at the end, the deployment of all of the Lambda functions takes about 10 minutes or so to get, work through the deploying of the Python and Node.js functions. And then finally, the initial compilation of our Java libraries, and then the deployment of the Java Lambda functions. After that deployment's done, we go in, we start up our sample application by calling the start.sh script. That script then just goes in and, generates our, starts up our Docker Compose application. Then once we have that up and running, we give it a couple minutes for everything to come online and get fully baked in. And then we kick off load. It's just a start load script file that we're just generating a series of, URLs to call, somewhere, for each of these segments, we call, each URL anywhere from 1 to, 5 times each. And then we just loop through that infinitely. And just for grins, I kicked up this load about 3 or 4 times so that we should get some good traffic coming in. And so ultimately something like this is what it ends up looking like before we get into any actual instrumentation.
So Wade, while we're looking at this kind of present in time dashboard right here without any Lambda functions or instrumentation at this point, while you're generating the load in the back end, it's good to call out that we're actually using AWS Cloud9 on the back end to run through this environment, which is our cloud-based IDE. You can just code with a browser, and it's been a very attractive tool of choice to build serverless applications with ease from our community. So I just wanted to point that out. There's other best practices and recommendations on the back end when spinning up this type of an environment. One of them in which as well is also leveraging IAM. So you want to make sure when you're deploying these this serverless instrumentation within your environment into the AppD backend that your resources are abiding by the the principle of least privilege, as always, right? Essentially granting the only permissions that are required to complete a task for any given individual role or service, right? So that's just best practice to make sure that you guys are well architected as we proceed on with the demo here.
Absolutely. Thanks for bringing that up. And to add on to that, because we are using Cloud9, and we know that cloud spend is something that people need to be conscious of. For the lab environment, we wanted to make sure that the underlying EC2 instance that powers the Cloud9 has enough oomph to actually run our lab application, but we don't want to over provision it and essentially give you keys to a proverbial Lamborghini when just something a little bit more reasonable will do here. So for the lab, we're using I believe we are, let me double check myself, but
T3 medium.
Yes, thank you. We are using a T3 medium. When we were building this out, we explored, using, T3 micro or T3 nano. But because we are doing running multiple services within Docker Compose, it needed just a little bit more oomph to get this going and to be performant. So we bumped this up to a T3 medium. And for the underlying operating system, we are using Amazon Linux 2. And Todd, I know you had some things that you wanted to call out about Amazon Linux 2.
Yep. Yeah. Just in terms of the OS that AWS is managing, right? It's something that includes a lot of support for the latest EC2 instance capabilities that are out there. So it's a stable release. We continue to manage all of the maintenance updates that are out there. And it's just it's a great way of getting started when the packages are already included. It's just easy integration. So it's a great starting point. Amazon Linux 2 is underlying this Cloud9 instance that we're running out today.
Perfect. Thanks for the background on that. And I know that was one of the things that we were looking at when building this out. We originally started with Amazon Linux, and then as we were starting to wrap up our build out of this lab, we decided to make the move to Amazon Linux 2 to address some of those things that you were talking about. But enough of me yammering around. Let's get started on some of the fun stuff. So we're going to tackle Python and Node.js today. First off, we're going to start with Python first. The architecture of it is for Python and for Node.js are very similar. For this, we're going to be, for our initial instrumentation of our Lambda functions, we're going to be taking advantage of the Lambda runtime extension that we have for AppDynamics, and that deploys our tracer without any kind of need to modify any code within your Lambda function. And that gives you the default capabilities for deploying and adding instrumentation to your Lambda functions. So here's just a quick chart of what that looks like. You just have your AWS Lambda function, and then we deploy the runtime extension as a Lambda layer. And so that wraps, before that Lambda function is executed, and when it spins up, we come in and we add in our bootstrapping code to add in instrumentation and add in all the hooks to send telemetry data as needed without blocking any executions that might be taking place.
And Wayne, in terms of deployment, I know we've already touched on this, but just for the audience, customers have the option to deploy extensions as layers and use the environment variables to configure them.
Yes.
But in this case, what we're doing is we are actually packaging and deploying our Lambda functions as container images. So you can then add your extension directly to the image, right?
Yep.
Now, in terms of use cases, now that we have the architectural deployment down, there's a lot of use cases out there for AWS Lambda extensions, such as capturing diagnostic information at all phases. I talked about the lifecycle earlier, right? You can think about fetching configuration settings or secrets prior to invocation. Or, interestingly enough, talking to an observability partner, just sending all the telemetry information back over to the controller and different customer destinations. So Wayne, maybe you can just double down and introduce the use case that we're building the extensions for.
Yeah. So why we went the route of using the Lambda extension layer is for that ease of adding instrumentation to your Lambda functions, rather than having to involve your development team to add in the required code necessary to monitor the specific things that you're interested in. We're taking advantage of that bootstrapping capabilities and the functionalities within the Lambda runtime extension framework to just automatically do that for you. But we also know that there sometimes is some flexibility that you need to maybe add in some additional things that you want to have represented within the AppDynamics that we may not necessarily do out of the box. So as kind of the second part of this, we're going to first add in the configuration and everything that's needed for the to use the Lambda extension layer. We're going to get that initial instrumentation in place. And then once we have that in place, the next thing that we're going to do is we're going to add in some customization to the Lambda function itself so that you can have the representation of, communicating to your different resources, such as DynamoDB or S3. So we're going to go ahead and get started with Python-based Lambda functions. And I'm actually going to start with our serverless YAML file. What I've learned is that the serverless framework is kind of that. I like to think of it as like a serverless equivalent of Terraform. Very focused around cloud infrastructure, and I found in working with different customers that this is a standard that they use for their applications and their deployments within cloud environments. So we're gonna first work within this serverless YAML file. The things we're going to do, we're going to add in our instrumentation first. We're going to add in our Lambda layer. We're going to add in the required environment variables that are needed to activate that Lambda layer and start sending telemetry data into AppDynamics. And then after we get all of the bits and pieces in, we're going to redeploy our Lambda functions. And then after those Lambda functions are deployed, we're going to let that run for a minute or two and start seeing how AppDynamics brings in that additional data after the instrumentation's been put in. How does that sound?
Sounds like a plan.
All righty, let's do this. So as part of our as part of the lab, we utilize a lot of environment variables. So I'm going to go ahead and clear out our terminal screen, and I'm just going to make sure that my AWS region variable that I have set here is set. In this case, it is US East 1. We are running this Cloud9 instance within US East 1, so we are going to be good to go here. Next thing we're going to do is I'm going to shrink this down a little bit so that it's a little bit easier to see. I'm going to clear this again, and then I'm going to open up our serverless YAML file. And what this does is this, provisions the AWS Lambda functions that we're going to be using, as well as any other kind of dependencies that are needed here. In this case, for our Python function, we are going to be taking advantage of S3. So we do have an S3 bucket that's going to be allocated as part of this overall grouping. For the provider, we are, this is an AWS Lambda function, and we have that specified here within our serverless YAML file. And we also, as we scroll down, we see the different IAM role statements that we attach to the Lambda functions itself. So we're not going to, just give it carte blanche access to do, anything and everything within the cloud environment. We scope it to that least privileged access needed to accomplish our functionalities. So here the things that we're attaching here, we're going to have it allow to invoke other Lambda functions. And then we're going to also allow it to be able to put objects, get objects, and delete objects from an S3 bucket. And then we scope that to the S3 bucket that's eventually created whenever this is deployed. And then as we scroll down, we see, information about the S3 bucket that we're creating. The name of the bucket we actually specify as an environment variable within our YAML file. And we also, add in some life cycle configurations so that, we delete content out of the S3 bucket after a day. Because if we let this run and run and run and run, that S3 bucket's going to keep filling up and up and up and up. And because this is a lab environment, there's not really any need to do that. And then finally, as part of this serverless YAML file, we actually define the functions that we are that we are deploying here. We have two different ones, Lambda 1 and Lambda 2, pretty self-explanatory names. We also have attributes and properties about those Lambda functions themselves. For the first Lambda function, when we built this prior to the function URL feature being released. So we're also deploying out an API gateway as part of this. And we specified that as part of this events to show how we're invoking that. And so this gets invoked via an HTTP API gateway. If we're having more granular details, we can, specify, the path and methods that are utilized to, invoke this Lambda function. But in this case, because it's a lab environment, it's not meant to be production grade. We're just, anything that's coming in through that API gateway, we're going to have it invoke this Lambda function. And then finally, we're also specifying an environment variable that is specific to this Lambda function itself. We see it's called AppDynamics tier name, and then we reference back to the name of our overall service, and then we append Lambda 1 to that. So now that I've given the little bit of a deep dive into all of the things that are part of this, the next thing I'm going to do is I'm going to open up this file that is called Lambda environment variables. And so as part of our bootstrapping process for setting up the lab, we auto-generate most of the environment variables that are needed to execute this. As part of the AppDynamics tracer, we do require environment variables to be attached to the Lambda functions in order for the tracers to be able to send in data. So now what we're going to do is we're going to start adding in those Lambda environment variables. So the first thing I'm going to do, because these variables are common across both Lambda functions, I can actually set it at the top level so that it gets propagated all the way to both Lambda functions that are part of this serverless application. So now it comes the fun part of just copying and pasting all of the values. And whenever you bootstrap your environment and scaffold it up and get everything set up, all of this will be auto-generated for you. So we will provide these different things that will that are needed here. So putting in the URL of the controller that we're using, which is channel.sas.appdynamics.com. And then one other piece that we are adding in is for whenever our traces from our serverless functions are sent, we need to let our tracer know where these need to be sent to. And so we specified that as part of this AppDynamics serverless API endpoint environment variable. Currently, we have 3 different endpoints that are available. We have them for 3 of our regions where we have our SAS controllers deployed, Portland, Frankfurt, and Sydney. And because I'm running this in US, I'm going to use the API endpoint that is based in Portland. And then finally, as we know, sometimes there are issues with the tracer, and we can set log levels for that. So as part of this, because I want to see, in the event that something goes wrong, because inevitably, live demo, it's always going to blow up. I'm going to go ahead and set the log level to debug to make sure that everything looks fine and looks as it should.
And as an FYI as well, Wayne, everyone that's following along here, as they run through the workshop, they can also consult their CloudFormation template that'll be running in the back end to take a closer look at all the different resources that have been created, the policies, the Lambda functions, Python, Node.js, and if you're running through the lab in its entirety, Java as well. You can track everything from there, make sure that everything was created successfully and that everything is in scope of the policies that are needed.
Absolutely. And then at the end of the lab, as you tear this down, we do have a tear down script that we run. And sometimes for whatever reason, sometimes the tear down script doesn't delete everything or gets stuck on deleting something. You can actually reference back to the cloud formation template that is created and go in and further triage and troubleshoot at that point. So to continue along, in order for the Lambda runtime extension to activate and wrap around the function that's being executed, the Lambda runtime extension uses a environment variable called AWS. I'm just going to copy this here. It's called AWS Lambda exec wrapper. And as part of this, this lets the extension know, hey, what are we calling in order to bootstrap everything? And so the script that we have within our Lambda extension is called opt AppDynamics extension script. It's pretty straightforward. So we go ahead and set that environment variable here. And now that we've got everything in place, we are ready to go for the next step of configuring within our serverless environment. Now we're going to add in our Lambda layer. So here at this part, we will now attach the Lambda layer to each of the individual functions. Sometimes you may not want to, have a particular Lambda function instrumented. In this case, because this is our lab and this is something that we want to show off, of course we want to instrument this. So we're going to then come in and add in another property to each of the Lambda functions. We're going to add in a layers property. And then at this point, we're going to specify this in ARN format. And we're going to copy in, the fully qualified ARN of the Lambda extension. It's a pretty familiar format for those who are familiar with working with ARN. The one thing I do want to call out here is this piece right here, where we're talking about our region. With AWS Lambda layers, you can only consume layers that reside in the region where your Lambda function is running. So as part of this deployment, we have this all set up within our serverless YAML file. Here in this case, I will see here that we have our region. Let's see if I can find where that region is. But we have our region already set up and in place, and it's part of this overall deployment. So we just reference this within the serverless YAML file, and this ultimately gets compiled into a CloudFormation template that is utilized. So then, we know what we have our region that this is running in. We have the account ID of where the Lambda layer resides. It's a layer, and then the name of the Lambda layer itself, and then the version number. So we're then going to take the same thing, and we're going to add it to our next Lambda function here. So we're going to make sure that both of our functions have the Lambda layer attached to it, and we're going to save these changes. Now that we've finished up all of our initial work that's needed to get that instrumentation into place, so now our next step is to come in and deploy the Lambda function. Now I'm going to come in and navigate to the Python directory. This is where the all of the infrastructure and all of the code base is for our Lambdas. I'm going to take that now, and next thing I'm going to do, I'm going to verify again that our AWS region environment variable is set, and then I'm going to call the command serverless deploy, and then I'm going to specify the region where it's going to deploy, and then we're going to let this run, and we're going to see how everything is put together. So now at this point, the serverless framework is packaging up our Python Lambda functions. Once it gets everything packaged up, it's going to then upload it to AWS, and then we'll generate the CloudFormation templates to have that update with the latest version. Todd, how is this going? And you have any questions about what you're seeing so far?
Yeah, I think the configuration is very straightforward. We have it all pre-configured in the workshop. Both functions have been updated, so we'll let it run. And the goal here is to then jump back into the AppDynamics controller, take a look at the dashboard, specifically the flow map for the application for this use case. And we'll take a look at how you can now visualize your different Lambda functions and the interactions that they're having within the application itself. So that's really the bread and butter and the exciting piece of this, of being able to have that single pane of glass as someone who is comfortable working within the AppDynamics platform, who this is their world, and now they're able to pull in information from a serverless perspective through AWS's platform right into where they're very comfortable working out of.
Absolutely. Absolutely. And so now here, as we continue to look at our progress, we now see that our CloudFormation stack is updating, and we're watching the progress of this. And sometimes it's a little bit like watching paint dry, but it's very verbose and gives you good information about how things are progressing. So here in this case, we have 10 different items that are part of the overall CloudFormation stack. And that includes, the IAM role and the permissions within that role, the Lambda functions themselves, the API gateway, the S3 bucket, and any other additional dependencies that are part of this. And after we finish up the instrumentation within Python, we'll go through Node.js. We'll see that there's a very similar process for doing that update as well. It's going to follow a very, very similar pattern. We will, add in the required bits needed in our serverless YAML file. We'll redeploy the serverless function, and then we'll see how things are updated. So while this is going, I'm going to go ahead and jump into do a little bit of a comparison between what we support within Python and within Node.js. So both our instrumentation capabilities for Python and Node.js, we both are able to automatically detect, calls that go out from one Lambda function to another Lambda function. So if you have tracers on both of those functions, and that first tracer calls the second tracer, we'll be able to draw that correlation between the two and show the data flows between the two. And we also will show calls out to third-party HTTP endpoints, whether that is some kind of external service, maybe such as a payment gateway, or, calling into some other third-party service that you may have subscribed to. We will also show calls that go out to that, and they'll look like the little cloud icons that we looked at earlier. Where we have our differences that come in is when we released our capabilities for serverless. Java was our first supported language. Then we followed it very quickly with Node.js. And then Python has been the most recently released language. So we've actually built on the capabilities of those. With our Python-based Lambda functions, we can also automatically detect calls that go out to a DynamoDB instance. So we'll surface that up automatically within our flow map in AppDynamics. But as part of the lab, we wanted to show capabilities of how does this work whenever I want to surface something up that isn't automatically detected out of the box. So for our Python functions, we're having those put data into an S3 bucket. So I'm going to go ahead and swap back over to AppDynamics. And now,
while you do that, I have a quick interruption because you brought up these different languages. I have to ask this question: which one is your favorite?
Which one is my favorite?
You said Java, Node.js, Python. I don't want to get into wars, anything like that. I just want to ask you a question.
Yeah, I've been, I'm pretty agnostic. I'm pretty much of the mind of the right tool for the right job. Sometimes it's quicker to break out Python. Sometimes, Node.js has been kind of my, love as of late. I've also done a lot of work around, with Java-based functions. And long time ago in a galaxy far away, I also did, development within .NET as well as PHP. So I'm pretty agnostic as far as languages go. I don't have a deep-rooted love for a particular language. For me, it's a right tool for a right job.
And I see in the comments as well, Jeong, that just came in around Python. I'd have to +1 that for Python as my number one, especially as within the observability space, machine learning specifically is
Exactly.
is really taking off, and observability machine learning space, not only just for anomaly detection, but feeding the business in more of an automated fashion, being able to take all of the metrics, logs, telemetry data, and perform inference on it, provide that back to the business has been super exciting to see the rapid evolution within the industry.
Yeah, absolutely. When you start talking about, specific functionality, circumstances, there's always going to be a preferred tool. As you start doing things within, machine learning and data science, Python. That's where I would gravitate on that front. If I'm working within an environment that tends to be, a little bit more of a a strongly typed stack, I might go Java or .NET. It kind of floats in between, depending upon, what is the lay of the land there. Node.js and JavaScript, I've actually really liked working with that a lot. It has that flexibility of you can use it in the front end, you can use it in the back end, and it's just for me, it's a language that I enjoy working with. They all have their headaches, so I'm not going to, just blatantly praise them all, blindly, but, right tool for the right job.
And thankfully, there's, as far as internal processes are concerned, when we talked about the extension API, we obviously have language-specific environment variables that we'll be running through. If you think about Java tool options or Node options or even .NET startup hooks, you'll be able to utilize all of those with the extensions API.
Yep, exactly. So our Lambda, we've deployed our updates to our Lambda functions. So now we're going to take a look and see if this actually worked. So the first thing that I want to do is I want to move to our tiers and nodes screen. And so this just gives us a list of all the services that are running within our application. And the things that I want to call out here, I want to call out these two functions right here. So we now have confirmed that we're starting to see traces coming into into AppDynamics. And we see that because we see that our Lambda functions have registered within our application itself. Traditionally, AppDynamics has gone on a application tier node structure whenever monitoring services, but Lambdas, are very ephemeral, and they're not going to follow that rigid structure. So we kind of extract that up and go, okay, this is a bit of an ephemeral service, so we're not going to give it a explicit tier, but we're going to note that it's a Lambda function with the little Lambda symbol there. And so now that we've had some data flowing in, now that I've gone in and I've gone to our flow map, we can now actually see our Lambda functions that are coming in. We see that, here I'm going to, move some stuff around, which you can move these around to get better a view and to make things a little bit more organized. So what we now have in play here is we've now surfaced up our Lambda functions within our overall flow map. So we've been able to augment our, always refreshing application architecture here. And we now include Lambda functions within that. We see how we have our calls coming from our web API. It goes through our core services. We hit our candidate services service right here. And we can see now that instead of going to an HTTP endpoint like we see here with our other functions, we see the actual Lambda function surfaced up. And then we can also then see any further downstream dependencies with that because we've attached that tracer to allow that correlation to continue. We see it goes from Lambda 1, we go to Lambda 2, and we see both of these are hitting a third-party HTTP endpoint as it's represented right now. Spoiler alert, next part, this is an S3 bucket, and we're going to now next go and add in the customization needed to have that represented as an S3 bucket. How's that sound?
Sounds good.
Awesome. I like this. So let's come back here. We're back into our Cloud9 instance. Next thing we're going to do is we're actually going to dig into our Python function itself. It's nothing that is overly elegant or extravagant. We're basically simulating load that is going through an application. But the things that we're going to do here are we're going to now open up and update these two Lambda functions to now add in the necessary bits to have that represented in our flow map as an S3 bucket instead of, just kind of a generic endpoint. So normally whenever you are, importing libraries within Python, you have to be, as part of the build process, you have to bring in those dependencies. Because we're loading the AppDynamics tracer through our Lambda layer, we don't have to package up the actual tracer artifacts itself into the Lambda function. That resides and is brought in as part of the Lambda layer. So for this, we do have access to the AppDynamics library. Even though this is going to tell us, no, we don't, we do. Because it's being brought in as part of that Lambda layer. So we've got this added in. I suppose if I wanted to actually follow my own steps, I would put it under my to-do comment. So we're going to import our AppDynamics library, and now we're going to start adding in the bits and pieces needed to change the representation within our flow map. So where the calls are being made out to S3, we're going to scroll down within our handler.py file, and we're going to come down to around line 47, 48. We're going to be looking for, in this case here, it actually jumps down to line 56 because I added in some extra stuff to actually use our Lambda function URLs. That's one thing I also forgot to mention. We did modify the lab environment that you get out of the box. The calls that are being made to our Lambda functions, we're no longer running through an API gateway. We're instead using our Lambda function URLs to make those calls in from our upstream services into Lambda. It doesn't matter whether it is we're making those calls through an API gateway or if they're being invoked via function URLs. We still have that same, correlation. We're still able to draw that, hey, this is invoking this, and we're able to represent that. So now the next pieces that I'm going to do, this section right here, we're generating some dummy data here, and we're going to then upload that into an S3 bucket. And for some reason, if it doesn't succeed, we're going to return a 500 from that. Right now in our AppDynamics controller, that S3 bucket is represented as a third-party HTTP endpoint because under the covers, it's the invocation is done over HTTP. But what we're going to do is we're going to add in some code to wrap that so that we know, hey, this is an exit call, from our Lambda function, and we're going out to S3.
So the mechanism to collect the metrics itself, these 400 and 500 metrics, these responses, they're not collected out of the box with AppDynamics, but it's through the Lambda layer itself, as in addition to your machine agent extension, right? That allows us to get all of the metrics together.
Yes. And I'm going to show that towards the end. I'm going to show how we configure that to be able to grab those metrics. So next thing we're going to do, we're going to add in our exit call here. We're going to come in and we're going to go, I copied and pasted some code that I had on a different screen for efficiency purposes. And I'm going to update my formatting of my function because, well, Python. And so what I want to do here is I want to call out that, we are, defining the type of call that we're making. We're defining the type of resource that we're calling out to. In this case, it's a custom exit point type. We have it defined as a type of Amazon S3. And then we put in different identifying properties that let us know, hey, what bucket are we dropping this in? We have our bucket name saved as an environment variable. So we're able to denote that as, with the property of bucket name. And then because we're wrapping this all essentially within like a one-time use, we've defined our exit call manager. So we have that in place. And then here at this point, we've added this in. and everything is encapsulated, and we have ended the exit call here. So that in order to do within Python to wrap a call within an exit call within for AppDynamics to show a custom endpoint, it's a single line and an indentation of the code block. Simple as that, easy peasy lemon squeezy. I'm going to go ahead and save those changes. Were there any questions? I need to double check back here. Anything that we've seen come across? Any questions that y'all may have?
Not for me. I mean, you're doing a great job. So anything I could think of, you pretty much answered it within the next couple of minutes.
Yeah, something comes up, interrupt me. I did see a question around Graviton support. I don't know that answer. I need to find out around that. But as far as we're concerned, I'm going to say I don't know. I don't want to try to guess and give a wrong answer. I'm not sure around the question around support for Gravitron.
You know, there was one thing that we can kind of jump into is we essentially used the CloudFormation template. We created an API gateway on the back end with AWS Lambda extensions, but then we turned around and we had iterated on top of that architecture, and we had used AWS Lambda function URLs as well. And that's kind of a parallel topic, but I think it warrants at least clarifying so there isn't any confusion out there of what it was that we've done. At a later point, we went back and we made some updates to those endpoints.
Yes.
And basically, it's probably a good segue just to kind of just take 1 minute and jump into it as we share the blog here for AppDynamics function URLs, AWS Lambda integration. Basically, what it is it creates an HTTP endpoint that is associated with your Lambda function, which grants the ability to call your Lambda function outside of AWS from any HTTP client, right? This is the alternative to binding your Lambda function to an API gateway. And through casual conversations over the years with a lot of developers that I've had, they'll naturally stand up an API gateway backed by an AWS Lambda function from a CloudFormation template that they've saved on their desktop, right? Or they have it in one of their repos, and they will basically copy and paste all of that code from the template. And that includes CORS configurations. And it's a template, of course, that doesn't have any security issues. And they continue to reuse it over and over again. And the reason why they do this is, number one, because there's always been a dependency, an underlying dependency on API gateway to expose the Lambda function, right? And number two, if you think about it, it's another service to learn, and it's another service to configure and to test out. And a lot of developers have the use case where they just really want to expose their Lambda function from the internet and call it from their application, right? So this is catering to that use case in which you don't have to have that underlying dependency or have to learn all of those things. But that does not mean that API gateway is going away at all, right? There's still very much so warranted use cases such as throttling, request validation, authorization, and even just the AWS certification management integration. Right? That's so smooth. It's very well documented. And being able to have your certificates generated for the resources is very much so important in a lot of the use cases that we see out there today.
Absolutely, and more options are always better. Like if I have the pattern where I have a service and I just need to make a quick call, into a Lambda function, and I don't need the formalization of running everything through an API gateway. Kind of a webhook pattern. It's perfect. Function URLs are perfect for being able to utilize webhooks. It's to me that has been kind of the strongest case for Lambda function URLs. But there are also cases where you need more of those formalized API management specifications and more of the requirements around that. The authorization, caching, all of these other different things. More options are better, and you have it's different things for different uses. And the good thing is, it doesn't matter how you're invoking it, if it's API gateway or if it's through a function URL, we can still make that correlation from, upstream service into Lambda.
Yeah. Wayne, like you just said earlier, right tool for the right job.
Yep.
Sometimes you need it. Sometimes that simpler thing works out. Sometimes you do need those extra features, and just depends on what you're trying to do.
Exactly. That's exactly right. So to continue on, because we're an hour 10 minutes into this, we've taken our first Lambda function and we've added in custom code to be able to show an exit point to something that we don't automatically detect out of the box. So we see that here. We see where we've added that in. We're going to do a similar exercise with our other Lambda function. I've already saved the file. We're going to now open up handler2.py. It's a very similar type thing. This one is, instead of dropping info into an S3 bucket, we're now going to randomly select something in the S3 bucket and pull it out. We're going to do similar activities that we did before in our previous Python file. We're going to come in and we're going to, I'm actually going to do it on the right number because I'm a little bit picky like that. I'm going to go ahead and import in my AppDynamics namespace into my file. And we actually have two different calls that we're making to our S3 bucket. The first one is here on line 15. Where we're making a call to the list objects API list objects API for S3. And then the second one is, starting at line 21, where after we've already listed our objects that are in a bucket, we've randomly picked an object out of the bucket. Now we're going to grab the contents of that file. And so that segment starts line 21 through 23. So now, because we have making two different calls to S3, we want to represent those individually. So we're going to add that in. We're going to come in here and we're going to add in the same, very similar call that we did earlier. We're going to now, come into our point where we're making the first call to S3. Very similar. In fact, it might almost be exact like it was before. And then we're going to indent that to wrap it within our exit call manager. So now, instead of just making a call to list all the objects within an S3 bucket, we're going to wrap that within the context of an AppDynamics exit call, so that we can associate it with an actual S3 bucket as opposed to a generic endpoint. We're going to then do the same thing with our second call that we're making to S3. We're going to come in here and add that in. We're going to make that call to, we're going to take the call that we're making to get an object out of S3. We're going to wrap that within the context of an AppDynamics exit call manager. And if you look within the lab guide, we do have a file that shows what everything looks like already instrumented. So if you're just interested in jumping ahead and just getting things done, you can just grab that file and copy it and paste it into your lab guide. So that's all the changes that we need to make here. We're going to come in, we're going to save this, and then once more with feeling, we're going to come in and redeploy our Lambda functions. So we're going to make a call to SLS deploy -r. And then because we saved our region as an environment variable, we're going to pass that variable in to let us know what region we're pushing this to. And we're going to run this again. And we're going to go through the similar process that we did earlier with, we're going to package up our Lambda functions. We're going to, get the payload in. We're going to upload that payload to AWS. Then we're going to take our CloudFormation stack that represents the set of Lambda functions and their dependencies. We're going to update that to point to the new payload. Gentlemen, is this pretty straightforward so far? Does this make sense? And are there any questions that you have?
Yeah, I'm loving it. We're following this it's very straightforward. We're at the point where we can start looking into that load and what's being generated. And I think, just for the sake of time, maybe rather than jumping into kind of the Node.js portion of it, we kind of drill down in on those different requests, and we show you guys the visualizations that AppDynamics can generate as it pertains to the different serverless metrics, the logs, and
Yeah.
a little bit on what the machine agent is actually pulling in as well.
Actually, that's a good call. And I did, and we can do that while this is running. So I do want to show that off. So and also in addition to collecting traces and trace metrics around our functions that are being executed, we also integrate with CloudWatch to be able to pull in metrics from various services. This is something that I did pre-configure ahead of time for the purposes of this. But I will show how I did configure that. So within our AppDynamics commercial SaaS platform, we have this notion of a machine agent. And by itself, the machine agent will collect metrics about underlying infrastructure that is running on wherever that it's running, whether it's an EC2 instance or a traditional server or a virtual machine. With our machine agent, we have an extensibility model known as machine agent extensions, and this allows us to collect metrics from other sources, whether it's, for example, we're collecting something from an F5 load balancer, or in the case that we did with this lab, we're collecting it from CloudWatch, and it relates to Lambda functions. So there are two parts to this. So the first part is this monitor.xml. We did not make any changes to this, but this just defines, how the extension runs, gives us information about it, how often it executes, and where configuration files reside, as well as the actual Java file that it resides within. The meat of where we do our configuration for what we're pulling in is in this config YAML file. And so I'll go through this real quick. First part is this metric prefix. This is going to tell us where we're going to store all of these metrics in AppDynamics. I'll show you how that, how this correlates to what we look at in AppDynamics shortly. For our accounts, we have a display account name. So like in this case, because this is just a lab, I just say that this is part of a Lambda lab. For access key and secret key, we'll notice here that we don't have one defined. For this model, what we are doing is we are actually using the instance profile that's associated with this EC2 instance that's backing our Cloud9 IDE. And we have attached a role to the EC2 instance that gives us access to be able to query CloudWatch and pull the appropriate metrics. Some of the other configuration variables I won't dive into. Where we define what functions we're going to query for is in this dimensions section. We see, we're going to call it function name, and then values. We can either specify individual names of Lambda functions, or we can use regular expressions and wildcards to be able to say, I want all of the Lambda functions that start with appd-lambda and then have this this suffix here, right in the middle of it. Because if we look at our Lambda functions, if I switch back over here and I click on this one, we see how, they're named in a very similar pattern. It's appd lambda, and then the name of the language that it's written in, an auto-generated prefix, and then whether it's lambda 1 or lambda 2. So we have a pattern there that we're using in this case. Make sense? And then for this CloudWatch monitoring, we have either basic or detailed. With basic monitoring, we're firing off calls every 5 minutes. For detailed, we're hitting calls every 1 minute. So, the thing you have to be cautious about if you're making detailed calls is making sure you're not, exceeding any kind of limits when you're querying those metrics. So then the important stuff, with the actual things that matter, is in this metrics config section. And we have a set of different metrics that we're including here. The name of it, we alias it. The type of statistic, whether it's a sum metric, like a summation metric would be like number of calls. And like in this case, we have, in this case, this one is invocations, and it's average. So we're averaging out how many calls we're getting over each, particular time period. And then we can aggregate that up in a sum and then different types of roll-ups. We're also doing similar things for errors, dead letter errors, duration, and then throttles, whether your Lambda functions are getting throttled. We're collecting that data as well. But as since we talked a lot about function URLs, you've introduced some new, metrics that are being published, when those are being invoked. So we have included those in here. We have URL request latency. And one of the cool things about tracking that is, what's the delay from invocation, getting to the URL versus the spin up of the Lambda function. And so a lot of times, by being able to track that, you can denote, hey, am I running into any issues with cold starts on my Lambda functions? Like if I don't have any provision concurrency in place to, keep my functions warm, I might run into, some instances where my functions are, hitting cold starts. And so by being able to measure that, that lets us know, hey, this could be coming into play. And then the other two that we put into this example, URL 5xx count and URL 4xx count, 500 level errors and 400 level errors. So, you're tracking those as well. So we can grab those and bring those into AppDynamics. And what I want to do is I want to show how those end up being consumed into AppDynamics. So we've pulled up our metric browser, and this gives us ability to show any kind of metrics that we're ingesting into this application. Because we're bringing these in custom, I have this custom service called AWS Lambda Monitor, and now we can drill into different custom metrics. Because in this case, we're bringing in just an AWS Lambda Monitor. This is the only thing that we see. I might have extensions that are deployed also for maybe measuring EC2 instances, or pulling metrics that are related to ECS or SQS or any other type of service where CloudWatch is storing those metrics. We can drill into those and we can expand it all the way down. And now that we've gone from our, where we looked at our name of our display name that we looked at earlier, we're now at the, this is the monitor level, the account level. Now we're at the region, and now we're going to show the different functions that we're bringing in. In this case, we're bringing in all of our functions that are deployed with this lab. We've got our 2 Java functions, our 2 Node.js functions, and our 2 Python functions. For this, I will come in and just show some of the, just some of the metrics that we're bringing in. In this case, I don't know if we're bringing in, we are bringing in, we do have about one, 500 error, every, so often. We can also bring in info about some of the URL request latency. And this right here, this could correspond to when we actually deployed out a Lambda function. We could also surface up invocations, throttles, duration of the functions that are being executed, and we can, as well as concurrent executions if there are any. And by surfacing up all this data and then being able to take it and look at it in various time ranges, in this case, I'm going to double check here, but I think we may have gone out to 3 to 4 hours. Yeah, so we're a little less than about 3 hours worth of data here, and we can see how those metrics and how those things are performing. We see that we've got a little bit of a spike here. This could be something that we would want to look at if this was something that was a little bit more pervasive. Todd, I think this is what you were looking for here. Does this make sense?
It does. It makes perfect sense. And we had just shared out the function metrics as well that are supported with this integration. So anyone who's interested in serverless, who is using AppDynamics, can now see all of that from the dashboards itself. They can drill down on it in real time. Obviously, the latency one is very interesting. We had some comments in the chat about that. And interestingly enough, the logs as well that are associated with part of this integration flow through at the AppDynamics platform as well.
I had a quick question. Sorry to interrupt. What sort of, so we looked at the metrics, and obviously it gives you a very nice visual way of interpreting the data or consuming the data. What sort of things can you do from here in terms of there's some irregularities or maybe something is not as intended? What sort of actions could you take from the AppDynamics
I'm
portal
glad
or otherwise any kind of integrations that go with.
Yeah, I'm glad you brought that up, because when we bring these metrics into AppDynamics, it doesn't matter if we're collecting them natively with our agents, or if we're doing like we're doing here and using a machine agent to integrate in with CloudWatch. Once the data gets into AppDynamics, we're treating them as first-class citizens. And so, because we're treating them as first-class citizens, it goes through our computational process, where what we refer to as dynamic baselining. And we recognize that, applications aren't going to have the same amount of load all the time. Your load that you might have on an application at 2 a.m. on Sunday morning is probably not going to be the same as it is, Monday morning, 9 a.m. when things open up and business happens. So we recognize that. And so we constantly calculate and recalculate what is considered to be normal. And we don't only do it just for, a static threshold. We do it based on different aspects. So we do it, hour of the day of the week, day of the month. And we take all of those different things into perspective, and we calculate those different trends. So here in this example, we have four baselines that we define out of the box with AppDynamics, whether it's all data over the last 15 days, and then you have daily, monthly, and weekly trends. And then in addition to those that we get out of the box, you can also configure those for specific, time periods. For example, if you're running a e-commerce platform, Black Friday, that's the hottest time of the year. And that's when you're going to go from the red to the black. You know that your load is going to be, much, much higher than normal, or at least you hope it's going to be. So you're going to recognize and know that, hey, I need to account for, there may be a little bit of slowness, during this point in time. So I can create a custom baseline that accounts for that and takes that into consideration. And then as I'm monitoring, I can go in and, compare it against that and determine, is this normal based on the fact that this is, Black Friday or high season? And because we're taking all that baselining in, we can then determine what's normal. We do it out of the box based on standard deviations, but you can set static thresholds if that's what your standards are. And because we can determine what's normal, what's slightly out of normal, or what's way out of normal, we can create those health rules that we call them. And then as those health rules get into that warning or critical state, we can then take it and create alerts and policies that take different actions based on something being in that warning or critical state, whether it's, whether it is something that is, you're making a call into, like, create a JIRA ticket, or you make a call into some middleware platform that, orchestrates a war room and all of the different things that are needed for that.
Oh,
so
sure.
everything that comes in
well,
is first class.
Yeah, it makes a lot of sense because, obviously we've spent a considerable amount of time talking about, visibility, tracing, logs, and just aggregating all of that into a single platform, but it doesn't make any use if you don't know what to do with it. So
Right.
it's good to see you
Exactly.
taking that next step of action.
Yep.
Obviously,
Yep.
if everything looks good, then there's nothing to worry about, but as we all know, that is never the case when you're
Right.
running cloud native workloads. So
Yep, exactly. And I know we've got about 30 minutes now. Todd, do we want to try to squeeze in Node.js, or at least one part of it?
I think Node.js, and then also there's the Java component to it as well. So I'm thinking kind of in a cookie cutter fashion. They can still utilize the workshop, but what would be of benefit is for us to kind of, as we wrap up here, still talk about the correlations of what it is that we're doing, right? When you talk about some anomalies, right, Jeong, and there's different alerts, there's flagging, there's root cause analysis. There's a lot of functionality that's packed into the AppDynamics platform, where it'll allow for the context around critical functions within the organizations or within the applications themselves to be fielded up almost immediately, right?
Yep.
And even with that, there's the snapshotting functionality of the data as well. So when performance starts to consistently degrade, we're able to understand at what point in time and with what data we can have with the snapshotting technique.
Yep.
And then work backwards from there and traverse the whole application to actually view the specific lines of code where the issues are occurring, right? And that was one of AppDynamics' superpowers when it pertains to mission critical applications, such as an ERP system like SAP.
Exactly. And one of the cool, and something that I just popped up here, since we added in our custom code to be able to represent an S3 bucket, I just did a quick refresh into our flow map to see what's coming up. And lo and behold, we now have a representation of our S3 bucket on the flow map. So I will call out that it looks like we have duplicate things. We do have duplicate things, and that's because with our tracer, it picks up the out of the box functionality, and it does that automatic, detection of calls to external things. But then because of the extra code that we added in, we can also represent that as, hey, this is going to S3. And if I'm monitoring this and I say, okay, this is just noise I don't want to deal with, I can just right click on this and go hide, and it's now out of sight, out of mind. And I still have this representation here. And so what we've done here as part of this walkthrough of instrumenting a Python-based Lambda function is we've shown two different things. The first thing we've shown is the ease of getting that instrumentation into place right away with the least amount of configuration as possible. We did that accomplishing using our Lambda runtime extension that we deployed via a Lambda layer. And we got that out, and we rapidly, put that instrumentation in place, and we were able to instantly see, now we're getting that additional downstream visibility and expanding that architecture. The second thing that we accomplished on this is that, we were able to add in, some custom bits to give us a better representation of what's actually being called here. One of the questions I see in here, hiding that duplicate item. I'm not aware of a way to hide that manually, but once you hide it for the first time, it doesn't come back unless you just want to bring it back in. So for Node.js, it's a very similar pattern for doing the same thing. I'll just show you real quick what that looks like within the workshop guide. Adding the instrumentation, it's actually almost the exact same process. We add in our required environment variables. In fact, I'll just show what that serverless file looks like just to show the components that are in play. And for our Node.js functions, we have two different functions that we're deploying, and then we have another resource where we are also having an instance of DynamoDB. And so we have that dependency there. So when we first create this, we're creating the DynamoDB, we're creating the API gateway, we're creating the Lambda functions, all the permissions, everything else that's dependent upon that, and then we're pushing that out. Very similar pattern. We fill in these environment variables with the appropriate information. We add in our environment variable that tells us how to execute the Lambda runtime extension that lets us wrap the instrumentation around the function that we're calling. And then once we get down to our individual functions themselves, then we add in the Lambda layer for each of those functions to have it attached to that. It's almost the exact same design pattern that we did earlier with Python. Then when we go in and actually add in the custom exit calls, it's the similar pattern for that. We bring in, instead of doing an import, it's just a little bit more Node.js specific syntax. So we're bringing in this library instead of just AppDynamics by itself. Then we come in and we have code that we're adding in for adding in the exit call to our DynamoDB instance. So here, we can see this is what the code looks like that we're going to add in. In this case, because we're not doing We're not doing the same type of encapsulation that we did with our Python function. We're going to have to explicitly start the exit call and then end the exit call at the very end. So this is what that code looks like. Similar type properties that we're calling in. We're adding in exit calls. Instead of it being Amazon S3, we're calling it Amazon Web Services. And then because this is DynamoDB, we're specifying a vendor identifying property, and then we're just passing it the name of our DynamoDB instance. And then finally, after we've done our calls to DynamoDB, we explicitly stop the exit call, and that lets us encapsulate and wrap everything.
Hey, Wayne.
And so that's. Mm-hmm.
Hey, we have another question from the chat regarding the duplicate. I know we're going to back up a little bit. They're asking how do they identify the duplicates are the same without actually knowing what the code is?
Yeah, in this case, because we're adding in that custom instrumentation, I think at this point it's just, once you add that in and then you see kind of the before and after, that's going to be how we're able to denote that, hey, this new icon that's popped up on our flow map corresponds to what we're seeing here. And then also as we come in here and look at our flow map, I'm going to come back in and I'm actually going to unhide that, that service that we were looking at earlier. Just to show, what that looks like. If I'm taking a look here, I'm just going to drag this out just for visibility purposes. We can see that, we've got very similar calls between the two. And I think the reason that there's differences in response time, we're encapsulating some of the additional overhead on the call, whereas this is just based on straight HTTP. And so I'll just come in and hide this again just to make it look a little bit cleaner. Hopefully that answered the question. And because we added in that custom code, it was kind of that before and after to show, as data is going through our Lambda function and those exit calls are starting to be executed, then, we could see what happens before versus what happens after, and just able to draw the correlation that, oh, this represents what was automatically detected.
Okay, cool. Yeah.
I know we've got about 25 minutes left. I am going to attempt to at least get the auto instrumentation done for Node.js. Let's see. We're going to start the clock now, and let's see if we can get this done. So I'm going to go ahead and close all of my other files here that I was working with earlier. And I'm going to do a lot of copy and paste. So for the sake of time and speed, I'm going to open up my serverless YAML file that is for my Node.js Lambda functions. But I'm going to come in and I'm going to also open up the one that was for my Lambda functions, because I'm about to do a lot of copy paste here. I'm going to take all of these endpoints and all of this data here that I'm gathering, and I'm going to take it and I'm just going to copy it and I'm going to put it into place here. So it's going to be a similar set of data that we were looking at before. We have our required AppDynamics properties to let us know, hey, what controller and application are we going to associate this with? And then also adding in our Lambda exec wrapper environment variable that lets us know what to execute within our runtime extension. I'm not worried about anything that's based around resources. Now I'm going to come down to my Lambda functions. I'm going to grab the Lambda layers here, same ones that we used earlier within Python. I'm going to come in and I'm going to add those in as additional properties within my individual functions themselves. I believe, and I'm going to do a quick check to make sure that's all I needed to add in. We've got our AppDynamics environment variables. We've got our Lambda exec wrapper. We've got our functions themselves. We added in the individual layers. This looks pretty good to me. So I've gone ahead and I've saved this. And now I'm going to come back to my terminal window. I'm going to switch over to the directory where my Node.js functions reside. And I'm going to redeploy those Node.js based Lambda functions. Similar type thing that we did earlier is packaging up our serverless application. It's going to upload the artifacts to AWS. Then we're going to come in and we're going to update the CloudFormation stack to point to the new payload that we have just uploaded. For these Node.js functions and the load generation that I have going on, we are using the Lambda function URLs on this as well. So as my upstream services start to communicate into Lambda, instead of running through the API gateway, I'm using function URLs. And we can see how we were doing that earlier when we were looking at our metric browser. We could see invocations that were taking place there. I can show those real quick. We'll come back in, expand our Lambdas at region, all of our functions. Let's look for our Node.js functions here, and I know that it's Lambda 1 is my initial one. I can see my invocations. I can see my URL request latency, and then I can see the duration and see how those are following there. We can see that there's they're pretty tightly close to each other. In this case, I'm not running into any kind of cold start issues or any kind of significant latency between hitting that function URL and then actually invoking the Lambda. I'll close that out. I'm going to switch back over here. We're going to watch paint dry some more, and then we're going to see that we have updated our Node.js based Lambda functions. This is, again, this is using the serverless framework, which is an abstraction up, and then under the covers, it uses AWS CloudFormation to do all of the resource deployments. And we see here that we've got our endpoint that's in place here. This is the API gateway that was created when we initially deployed that out. We see the serverless bucket name. That's where our artifacts are stored. And we also have the qualified ARNs for the two functions that we deploy. Deployed this about 6 times, so we're on version number 6. Now I'm going to go ahead and switch back over here to AppDynamics. We're going to let this continue to run for a minute or so, and then I'm going to switch over to my tiers and nodes. And so I can now see here we've had our 2 Node.js functions that have popped up here. You'll notice that they're a little bit different than from our 2 Python functions. I'll dive into that real quick. So when we deployed our Python-based Lambda functions, for each of the individual functions, I specified a tier name to call those particular functions that we represent within AppDynamics. You'll see here that it's called, the name of the overall service -Lambda 1, and then this one is Lambda 2. So for Python, we explicitly named the Lambda functions as they're displayed in the AppDynamics flow map. Now, when I come to our Node.js based Lambda functions, notice here, I don't have that environment variable where I'm setting a tier name for AppDynamics. In the case where this happens, we automatically just pick up the name and version of the Lambda function that's being executed. So that's why you see that there's a big discrepancy in play here. So because now we're picking up the name of the kind of the overall application, a set of serverless functions and infrastructure as they're grouped together logically. The stage name of the functions themselves, in this case, we're calling it dev, and then the name of the actual function being Lambda 1, Lambda 2, and then we're finally following that up with the version of that, which in this case is just the latest version. And then finally, when I switch back over to AppDynamics, we recognize that, hey, we're picking up additional things. There's additional data that's coming into our flow map. So it recognizes that, and it sees that traces are coming in. And, as we're collecting all of this data, we're now seeing, hey, we've picked up, this first Lambda function that's being called. And as this continues to run and as we continue to get load on our application, we can eventually refresh this and we will eventually see that second function pop up on the flow map. And then as more data gets in, AppDynamics then recognizes, hey, I am 100% or 99.999% certain that this function talks to this function and these talk to this, external endpoint. And so as I continue to run this, I now see, hey, I've got some things that are going on here. I probably did something to screw up on my call. So that's how that works. And if I see that, hey, this isn't quite right, I can come in and see exactly what's going on.
And
So
one
we can
interesting
see.
thing to note, Wayne, as well, is that there's actually multiple run times that you're displaying from the dashboard itself at the same time. So it's not just one specific one or any overlapping ones or write-overs. If you have parts of your application that are being served with business logic from different run times of the underlying functions, you can see everything in one pane of glass here.
Yes, absolutely. Absolutely.
I'm guessing you
And-
could
and-
also separate those out, though, if you really wanted to.
Yeah, I believe so. Yeah, you can definitely, like, if you wanted to separate those out, you could. Awesome. I was able to get that done in, before the stream was to be finished. So, I think I'd given myself 25 minutes, and we were able to get that done in 10. So,
Yep, awesome job, Wayne. Really appreciate it. This was a great demo. Thanks for diving deep with us. And I think, interestingly enough, walking through the different underlying architectures that support not only AWS Lambda extensions, but the functions URLs and the iterations that we've made. And it's good to point out that during your journey to the cloud, AppDynamics can absolutely validate your modernization efforts through re-architecting application components to be cloud native. So Kubernetes, in this case, serverless, and we're happy to have been able to be given the opportunity to bring all of that to you today. And it's worth mentioning as a final note is that at AppDynamics, serverless is very much so a big part of their platform, and they have dedicated product management teams in the future. We're looking forward to working very tightly with you in terms of the partnership between AWS and AppD.
awesome. Yeah, thanks for that. And one other plug that I want to make next week is because AppDynamics is part of Cisco. Cisco has their big flagship event next week in Las Vegas, as well as digital. Cisco Live. It will be at Mandalay Bay. AppDynamics will be there with a big presence. We've got some cool things that are going to be coming out at Cisco Live. If you happen to be attending, please come by. Please say hello, and please check out some of the cool stuff that we have to offer.
Sounds good. I don't know if I'll be able to make that one, but just as for anybody who's watching, if you are interested in, what AppDynamics brings, and there was a lot of stuff that we went over today. So if you're watching live, or if you're going to be watching the recording, hopefully before next week, check them out. Las Vegas, who doesn't really want to go to Las Vegas for a conference? I mean, I love it. So hopefully, if you
and
do
after
go
not going
there,
anywhere for a couple of years.
right. So if you do go there, check out AppDynamics. Wayne will be there. Say hello. Wayne,
Yep.
any other ways for the audience to reach out to you for any sort of questions, just getting acquainted with your expertise, so on and so forth?
Yeah, absolutely. So I do have a presence on LinkedIn as well as on Twitter. So I can be found at linkedin.com. Let me double check my URL. LinkedIn.com/n/brownkw. Please connect with me. I'd love to connect and not only meet you, but also learn from you and your situations and your architectures. I can also be found on Twitter. I try to Twitter a little bit. So I'm at twitter.com, and my handle on there is the Wayne Brown. So it's twitter.com/the Wayne Brown. So follow me, I'll follow back. I'd love to learn from you. I'd love to connect. And if you're going to be in Vegas next week for Cisco Live, please come by and say hello. I'd love to meet you.
Awesome.
Excellent. Before we end, I know you gave out your information to connect. How would somebody who is interested in using AppDynamics get started? I know we talked about the workshop. Is there anything else you'd like to share that could be useful for
Yeah,
anybody?
yeah. If you are, if you're interested in giving taking AppDynamics for a test drive, you can go to our website appdynamics.com. We do have a free trial that's available on there. At the very top, we do give a free 15-day trial, and we're not just going to cut you loose on it. We are interested in making sure that you're successful with it. So, appdynamics.com, click the free trial link, and we'll go from there.
Sounds good. I think that's it. Thanks, Wayne, for showing us a great set of demos. I think this was very informative. Almost took up the whole 2 hours, but I think a lot of, and myself included, have found this to be very useful. I may actually just give it a free trial, to be honest.
Jeong, James, Todd, thank you again so much for having me on here. It's been a blast.
Yeah, and also appreciate you, Todd, for jumping on, helping us kind of drive some of the conversation. Again, this was Howdy Partner. You can check us out on AWS Twitch on Wednesdays from 2 to 4 p.m. So join us next time, 2 p.m. Pacific time for our next partner. I can assure you there will be other great content to look forward to. So with
Thanks
that,
again. Thanks again, y'all.
We usually have, sorry to interrupt, we usually have our way of signing off as part of Howdy Partner. And since you are the guest of honor, we'll let you pick one of the choices. So first one is Giddy Up. Second one is Happy Trails. And then the last one is See y'all next time. So pick one, and then we can do a countdown, and we can all say it together.
All right. So before I make my choice, I am based in Southwest Montana, so all of the choices are very applicable for me. But you said it was Giddy Up, and what were the other two choices?
Happy Trails or See y'all next time.
I'm wordy, so let's go See y'all next time.
Sounds good. So on a count of three, we'll do See y'all next time and sign off. So on a count of 3, 2, 1. See y'all next time.
time.
Take it easy, and thanks everyone again. Goodbye.